Insane SpaceX Raptor 2, step-by-step design, installation updates and performance. The incredible Raptor 2 engines from SpaceX are game changers for the whole space industry. They truly induce a massive push to the super heavy during liftoff. In fact, let's just say they are unlike anything else. To transport 100 humans into space, larger rockets are required, and these rockets will, of course, be driven by larger and more powerful engines. You may not be able to see how large the rocket nicknamed Super Heavy is in reality. Perhaps you've been hearing a lot about it on air, but we're trying to reveal that the Super Heavy is a big boy that is cylindrical in shape. It's so gigantic that it can cover up the size of a room. This is TechSpace. In this video, we will enlighten you about the step-by-step design and manufacturing process of the new SpaceX Raptor engine, before we talk about how it is installed under the Super Heavy, and finally, how these engines actually work. This is TechSpace. If you're new here, we specially invite you to join many of our lovely fans. Kindly subscribe and click on the notification bell. It motivates us to produce more fantastic content like this, and you will have a lifetime access to all of our high-end tech videos. As previously stated, the massive size of the Super Heavy rocket necessitates the use of a strong engine to raise it off the ground and resist gravity's pull, which acts in the opposite direction of the Starship's propelling force. As a result, after SpaceX estimated the weight of the entire Starship, as well as the weight of 100 people on board the Starship, combined with cargo weight, they concluded that approximately 29 to 33 Raptor engines should be attached under the Super Heavy to fire up the entire vessel so it could overcome whatever weight the Starship vessel will possess, as well as the gravitational force around the Earth's atmosphere, and finally shoot it into space. 6 more engines will be attached beneath the first stage Starship to launch it into other space bodies. There are little or no forces that will oppose the motion of the first stage Starship. That is why it will only need 6 engines to propel it. Because there are little or no forces opposing the velocity of the first stage Starship when it gets to space, it will only require 6 engines to propel it. Blue Origin's BE-4 engine, which we hope will one day power ULA's Vulcan, and Blue Origin's reusable New Glenn, was the most powerful methane and oxygen rocket engine ever tested. The BE-4 is capable of a thrust force of up to 244 tons. It appears that SpaceX's first completed Raptor 2 prototype narrowly beat out BE-4, generating a primary combustion chamber pressure of 321 bar and up to 245 tons of thrust. That is 1 ton more powerful than the BE-4. The thrust of the BE-4 engine may be the sole thing that Blue Origin borrowed from SpaceX, implying that it is not only Blue Origin and China's Roscosmos who are copycats in the space industry. At this point, SpaceX has also copied from Blue Origin. When SpaceX pushed the first Raptor 2 prototype to over 107% of its maximum rated thrust and main chamber pressure during its maiden test, it exploded. The Raptor 2 is one of SpaceX's most recent projects, and the company has previously said that the new structure will take over mass manufacturing of the type. Up till this moment, no prototype of the Starship, not even the Super Heavy rocket, has flown with the Raptor 2 revolutionary engine. Rather, for now, SpaceX is only running several flight tests on the Starship and Raptor engine. Although the test exceeds what the engine is designed to take, prior ratings of the original Raptor went far beyond and survived, so it's still unclear whether something went wrong during the testing or whether the engine's explosion was something the company had anticipated. According to Elon Musk, the Raptor 2 differs from prior versions in several ways, including stronger wire brackets, cleaner plumbing, and a far more open combustion outlet. Previously, Elon Musk referred to the project as an improvement in simplicity. Raptor is now available in 2 variants, one for use in the atmosphere known as the Raptor Center Boost, and another developed specially for use in the vacuum of space. To what benefits we have if we talk about rocket engines without touching how the engines work? Now let's move on to the topic of the day, and perhaps the very topic you've been longing for, which is, how does the Raptor 2 engine work? First, let's revisit our fundamental physics. Remember those days in college? We may have learned about the rocket equation and how it governs all rocket design. In particular, we learned the importance of specific impulse, a measure of a rocket engine's efficiency. So for the moment, let us revisit the inner workings of liquid-fueled chemical rocket engines, the workhorses of space travel, and the most likely propulsion source for the first human journey to Mars. While the average rocket engine is less complex than the average car engine, the difficulty of its engineering lies in the extreme conditions it must endure whilst remaining lightweight. The SpaceX Raptor is meant to provide kinetic energy to its spaceship at a rate of 11 million horsepower, which is the equivalent of 4 Hoover dams and is generated by a 1.5-ton engine. To compare, we may use a sample engine from a Bugatti Veyron, which is one of the most powerful sports vehicles ever made. The Bugatti Veyron's engine weighs 0.5 tons, 1/3 as much, but only produces 1,200 horsepower. Now increase this car's overall horsepower by 9,167 to achieve something close to the horsepower of one SpaceX Raptor engine. That is only one example of how powerful a Raptor engine can be. Still, SpaceX plans to place at least 29 people beneath the incredibly hefty rocket, and you can guess what that entails. Again, methane and oxygen burn at temperatures hot enough to melt the walls of a Raptor's combustion chamber, but this is avoided by regenerative cooling at pressures greater than those found in scuba cylinders. The exhaust is emitted at speeds exceeding 10 times the speed of sound. At the heart of all chemical, or more broadly all thermal rocket engines work basically with well-known thermodynamic principles, which affirms that when a gas is heated, it expands. Chemical rockets use a combustion chamber to burn fuel and oxidizer. This generates a tremendous amount of heat in the gases, forcing them to expand quickly. In other words, an explosion happens. This explosion occurs continually in a rocket engine when fuel and oxidizer are pushed in via a gas compressor. The heated gases are then accelerated to the speed of sound by forcing them through a converge constriction. They then proceed into the nozzle, which expands and hence diverges, propelling them to hypersonic speeds. The pressure and the temperature of the gas reduce as it expands and propels the rocket onward. As a result, its velocity rises. The pressure of the expelled gases pressing against the engine walls propels the rocket forward. This converging, diverging nozzle design is known as a de Laval nozzle, and it may be found in rocket engines ranging from small rockets to the massive F-1 engines of the Saturn V rocket. A rocket is essentially an effective technique of transferring the chemical energy of the fuel into kinetic energy. Propeller energy is turned into thermal energy when the propellant is combusted. The gas reaches tremendous pressures during the engine's resistance to the explosion. To boost the thrust of the rocket, more engines may be added or the rate of fuel consumption can be increased. This, however, will not boost the rocket's delta V. In a word, delta V is a rocket's capacity to alter velocity, which defines how difficult a mission it can complete. In reality, adding engines reduces delta V owing to the additional bulk. Remember from the rocket combustion analysis we just illustrated, there are possible ways to increase delta V, which is carrying more fuel or improve specific impulse. Specific impulse is the efficiency with which each kilogram of fuel propels the rocket ahead. To maximize this efficiency, we must carefully build and optimize the engines. There are usually a number of chemical possibilities that go down in the Raptor 2's burning chambers, but for now, let us simply get to you at this point. As for me, I consider the Raptor engine to be a miracle for SpaceX's space trips. So I doubt we'll see anything following Raptor, Starship, or Super Heavy in general for a long time. But we should be convinced that it will be a significant improvement over the existing concept. Obviously, SpaceX is the world's authority on reusable rockets right now, but as a result, they are staggering around in the dark, making it up as they go. If 29 or 33 engines are stacked to the Super Heavy, how do you believe SpaceX will regulate the heat created between these engines so that their components do not overheat and eventually melt out? Please do well to share your thoughts in the comment section below. Until next time, please like, share, subscribe, and whilst you're still around, why don't you click on one of those flashing videos on the screen for more content?